Welcome to our project on playing Doom using deep reinforcement learning. This project aimed to train an AI agent to master complex scenarios in the iconic first-person shooter game Doom. We use deep Q learning, also known as DQN, algorithm implemented via the Stable Baselines 3 library. Our journey began with foundational learning in reinforcement learning, inspired by David Silver's renowned lectures. We explored key techniques like Monte Carlo, Sasa Lambda, and Q learning, guided by Sutton and Barton's seminal book. Starting with simple environments like Frozen Lake and Minigrid, we gradually worked our way towards tackling the challenging Doom environment. The Doom environment, the agent received raw pixel data as input, representing the game screen. Its goal was clear: maximize rewards by learning to shoot monsters effectively. The action space was simple, with just 3 choices: turning left, turning right, and shooting. Rewards were assigned carefully, penalizing survival without progress or wasting bullets, and offering significant bonuses for eliminating monsters. Initially, the agent was clueless, wandering aimlessly and accumulating negative rewards. After 20,000 time steps, it began experimenting with its actions, slowly understanding the consequences. By the 50,000 time steps, the agent had become highly efficient. Not only consistently eliminated monsters, but also optimized its gameplay to minimize unnecessary actions, showing true mastery of the environment. The training process was vividly reflected in our results. The episodic mean reward graph revealed a dramatic rise from negative values to a steady high, indicating the agent's growing ability to hit targets. The episodic mean length graph showed a clear decline, illustrating the agent's efficiency in completing tasks. What began as prolonged games with little progress became swift, decisive victories as the agent improved. These results underscore the power of reinforcement learning in mastering complex tasks through iterative learning.